Imagine a vehicle that truly thinks. A car making, nuanced, real-time decisions, navigating dense traffic and adapting, all without you having to monitor it. That's the ambition behind this new buzzword, physical AI.
Right, and then you have to juxtapose that physical ambition with the massive financial signals we're seeing. I mean, a $12 billion valuation driven entirely by what the public actually wants to use AI for. We're diving into both of those today.
Welcome to the deep dive. Today we're unpacking a pretty substantial stack of sources that really map the current trajectory of AI, from these huge engineering goals of automakers all the way to the edge of theoretical research.
Yeah, our mission is to trace that blurring line between the digital code and actual real-world results. First, we'll get into that fight to own the operating system of autonomous vehicles, what the industry is calling physical AI.
Then we're going to shift to the front lines of practical research. I mean, everything from an AI keeping a real plant alive to the complexities of self-mutating code.
And finally, we'll analyze that historic IPO. It proves pretty clearly that, for today at least, consumer apps are absolutely king.
Okay, let's unpack this. So we're starting with that idea, physical AI. It's the new term you see flooding the auto industry, robotics, logistics. It's all about autonomous systems that can think, reason, and, act in the real world.
And what's fascinating here is just the terminology itself. I mean, let's be honest. Physical AI is essentially a rebrand of high-end robotics.
Yeah.
It makes traditional automation sound new again.
But the key distinction is the scale, isn't it? We've had robotics for decades, but the innovation now is applying these massive deep learning models to unpredictable situations like a city street.
Exactly. The old systems were brittle. These new systems, the ones powered by so-called physical AI, they're designed to reason through billions of data points. They have to understand physics, human intent, probability, all at the same time.
And we are seeing real products emerge from this, like the Sony and Honda collaboration, the Afeela EV. Their goal is full level 4 autonomous driving, using a physical AI system to constantly process what's around it.
And this is a huge global commitment. Ford has been really aggressive, promising cars by 2028, where you won't need your eyes on the road at all, not just monitoring, but truly hands-off. That timeline is, well, it's very aggressive.
And to get to that level of reasoning, you need computing power that rivals a small data center, but inside the car itself.
That's why the chip war is so intense here. Every new feature needs exponentially more compute, more memory, more sensors. Nvidia is supplying chips to giants like Geely and Mercedes.
Yeah.
ARM is dedicating huge resources just to designing chips for these systems.
Mercedes is playing it a little safer, though. They're focusing on a really defined use case. They're saying their new system will drive you specifically between home and work. That's it.
And that detail really highlights the core strategic battle. Everyone involved wants to own the OS, the actual operating system of autonomous things. You control that layer, you control the updates, the subscriptions, the whole revenue stream.
So this raises an important question then. If physical AI is just a rebrand, what's the true innovation here? Is it just the software, or is it the scale of the data processing?
The innovation lies in scaling AI to real-world tasks and handling previously unimaginable amounts of dynamic sensory data.
Okay, so moving from that intense engineering of the auto world, let's look at the sheer breadth of AI applications happening right now. It is truly wild.
It really is. The evidence that these general models are becoming super adaptable is just everywhere. We saw this research where the Claude model successfully kept a real physical plant alive.
A physical plant? How did it do that?
It monitored images of the plant, analyzed sensor data, and then calculated the adjustments it needed, light, water, temperature, to keep it healthy. It wasn't perfect. I mean, it had to adapt and recover the plant after a few failures. But the fact that it learned to manage a tangible biological system, that's a huge step.
And on the accessibility side, the bar for entry just keeps dropping. If you've never coded, there's a new course showing how you can just describe an idea and build an app in under 30 minutes. Zero coding required.
That accessibility is a massive socioeconomic shift. And speaking of data, you have projects like the Situation Monitor. It's a live map tracking global conflicts, nuclear facilities, military bases.
And what was that surprising data point they included?
The Pentagon Pizza Index. It's a little bit wry, but it measures how often high-ranking officials order late-night pizzas. It's a proxy for, intense after-hours emergency activity. The variety of data is just bizarre and fascinating.
We're also seeing AI take over commercial processes. The shift in commerce is huge. Microsoft's new Copilot Checkout just joined this growing list of AI shopping agents from OpenAI, Perplexity, Gemini. They can actually buy stuff for you now.
Yeah, it removes a lot of friction for the consumer. And speaking of big models, Elon Musk recently teased a major upgrade for Grok Code, claiming it's going to be able to one-shot complex tasks, just one command, and it generates the whole thing.
That sounds incredibly powerful, but there was a significant ethical issue with Grok recently, right? With its image generation.
Yes, X had to restrict Grok's image generation to paying users after a backlash over non-consensual AI images. And while they responded, a paywall is a shaky safeguard. It really highlights that tension between utility and guardrails.
That tension doesn't seem to be slowing down investment, though. Whoa. Imagine scaling to 1 billion queries. The investment signal here is truly enormous. We're seeing OpenAI and SoftBank putting a staggering $1 billion into SB Energy just for data centers. And that's all feeding into that $500 billion Stargate expansion plan.
So when you look at all these incredibly diverse applications, from a plant to e-commerce to needing $500 billion for data centers, what does this rapid expansion tell us about the state of general AI models?
General models are proving adaptable across incredibly diverse, tangible tasks, driving massive infrastructure investment as a result. Now we step into the research labs, the bleeding edge, where they're trying to solve the core problems of these AI systems. I still wrestle with prompt drift myself, so I always appreciate new ideas for managing AI memory.
You're not alone there. Prompt drift is where the AI just sort of loses track of the initial instructions as the conversation gets longer. It's a fundamental challenge.
And that's where these hot new papers come in. One proposes managing context like a file system.
Right. Instead of one long scrolling document that the model has to keep rereading, every memory, every tool, every note becomes a distinct file with its own history. So organizing the intelligence so the AI can pull exactly what it needs instantly.
And then there's another approach, focusing on efficiency through recursive memory.
This is fascinating. Instead of those huge bloated prompts that waste compute, this new framework uses sub-LLMs. And just to be clear, an LLM is a large language model, the kind of AI that processes human text to slice up data locally. It keeps the main model lean and focused. It's like modularity for thought.
That sounds incredibly efficient, especially for something like software creation.
It is. And speaking of that, Deep Code on GitHub is using a multi-agent system that takes research papers and turns them into full code bases. It even generates its own tests to verify the code. It literally reads the science and then builds the software.
On the perception side, we're seeing multimodal advancements. Alibaba released Qwen 3VL, a model that ranks text, image, and video all in one shared space.
And it achieved outstanding results on MMEB v2, which is a really respected benchmark for measuring how well a model understands information across different formats at the same time. Strong performance there means true, holistic understanding.
But maybe the most critically fascinating research, and maybe the most provocative, is coming from MIT and Sakana AI.
I agree. They ran core war battles, which is this digital arena where programs fight to overwrite each other's code with AIs that can mutate and learn through self-play. The research showed early signs of emergent strategy, where the system changes its own code to get an advantage and win. That's a fundamental leap.
And alongside all that research, we're getting powerful new tools. Gmail in the Gemini era now gives you smart summaries just by letting you ask your inbox questions. It turns your email into a database.
And for researchers, Chirp's agent is a huge asset. It searches over 280 million papers, ranks them, summarizes them, and gives you trusted citations. It just slashes your review time.
So if the future is built on this recursive memory and multimodal models, which area rapid code generation or this complex self-mutating strategy is going to provide the biggest leap forward?
Complex strategy, like the self-mutation research, offers the most significant leap forward because it fundamentally changes how quickly a system can learn.
That discussion about emergent strategies sets the perfect stage for the big financial signal we saw. The business world is paying attention, and the headline is huge. China's MiniMax, barely 2 years old, just pulled off one of the most remarkable IPOs in recent memory.
The metrics are just staggering. The IPO raised $619 million, hitting a $12.8 billion valuation. And the shares surged over 100% on day one.
And what does that surge tell us about investor sentiment?
It tells us the appetite is ravenous. The IPO was 1,837 times oversubscribed. Hong Kong hasn't seen a tech IPO pop like this in 4 years. It's a massive market validation for a very specific type of AI.
And they clearly mastered the formula. They're building applications on top of powerful models that people actually use day in and day out.
That's the core of their valuation.
Yeah.
Their key apps are so instructive. Talkie, which is an AI character app focused on emotional companionship, and then Hailu AI, a generative video creation tool. They targeted connection and creation, two deeply human needs.
And it's not just a shiny front end. They have the back end strength to support that value.
Absolutely. MiniMax is a full-stack AI company. Their open-source models consistently rank near the top in industry benchmarks across text, audio, video, music. They have the deep tech and the successful consumer app. That's the combination investors love.
So if you put all that together, what's the single biggest takeaway from the MiniMax IPO?
The public markets have made it crystal clear. Consumer AI is king right now. Training the biggest models isn't enough. The intelligence has to translate into direct, functional, desirable apps. That's where the money is right now.
So what does MiniMax's success, focus so heavily on these companion and creator apps, suggest about the immediate monetization path for foundation models going forward?
Immediate monetization favors applications providing emotion connection and powerful creative production tools.
So what does this all mean when we connect the dots? We started with physical AI, this ambition for code to leave the server room and drive multi-ton vehicles, manage real-world systems.
And we saw the research push toward leaner, self-improving memory systems, like that file system approach, to solve critical problems like prompt drift so models can handle complex tasks.
And maybe most importantly, that massive $12.8 billion MiniMax IPO confirmed the market's current mandate. Intelligence has to translate into consumer apps that satisfy core human needs, like creation or companionship.
Right, and we saw that MIT research on AI systems that can mutate and learn through self-play just to gain an advantage in a simple digital war.
Huh.
That concept is maybe the biggest idea from this whole deep dive.
This leads to a final provocative thought for you to mull over. If an AI system can develop truly emergent strategies, if it can automatically mutate its own code to gain an advantage in a closed digital environment like Core War, what does that concept imply for complex real-world systems? Like, say, autonomous traffic flow across a major city, or global supply chains where the environment is constantly changing.
That shift from program learning to self-directed evolution is, well, it's the final frontier, something to think about until next time.
We hope this deep dive gave you some new insights and questions to explore. We really appreciate you spending this time with us.